Hello everyone. Today we are going to solve this Edexcel chemistry paper foundation, which is from 2024. So let's start with our questions. So before going ahead, if you want to take my free classes, free live classes, you can join me on Teams. And if you want link, you can contact me on WhatsApp. This is my number 9205948909, or you can comment. I can give you link there on my YouTube video, and I take every day free class for GCSE math and science. We are practicing lots of concept and previous year paper. So it is going to be really helpful if you want to join this. In science, I take bio, I take chemistry and physics, all of them I'm teaching, and we are practicing lots of paper. So if you want to get benefit, you can join. There are lots of other students who are already and who has already joined me, and it's free of cost. So let's start with our paper. So we have a figure 1, which is showing a test tube being heated in a beaker of water, and there is wax, solid wax. So as the test tube was heated, the solid wax changed into liquid. So after heating, the wax was allowed to cool to room temperature. Okay. So this is showing the liquid wax arrangement of particles. We have to draw here solid wax arrangement of particle. So basically, solid is, we know particles are arranged in solid very tightly. So there should be no large gap between the particles. As you can see here, liquids are also arranged closely, but there is a gap between them, right? Here you can see gap because this is liquid wax. But in solid wax, there should be no large gap between the particles. So we need to make a neat repeating pattern like rows and columns. These are particles, and because solid particles are tightly packed, so make sure there is no gap, and like this rows and column you can make, and, so there should not be any gap like this. And if suppose it asks for gas, so then the gap is going to be too much, because gas particles force is very weak and they move randomly, and there is a intermolecular gap space between them. Okay, let's go to next one. Next question is, when the wax cools, it changes from liquid back to solid. And this physical change is, this is called freezing, like freezing of water into ice cubes, right? Because it is freezing, so this is called freezing, means a liquid to solid. Explain why this is physical change, not chemical. So to, because chemical change means if there is a new substance forms, that is called chemical change. Sorry. So this is a physical change because there is no new substance formed. So no new substance formed, chemical composition of wax remains same. It is still wax, right? The state has changed, but it is still wax. Because it is 2 marks, so write one more point. It is reversible, right? I'm just going to write main point. Make sure you write proper line, proper statement. Solid wax can be melted back into liquid, right? Simply by heating it again. So the only thing happened here is change in state. It only involves change in the physical state of matter from liquid to solid due to heat. Okay, next is another physical change is when a liquid changes into gas, right? So which row is showing the movement and arrangement of particle in gas? So particle in gas, they have high kinetic energy and they move fast in all direction, right? So it is, the slow cannot be the correct option. And particles are far apart with no fixed pattern like this randomly. So it is fast and random, this one. So option D is correct. Suggest why the wax did not change into a gas when the test tube was heated in the beaker of water. Okay, so why it did not change into gas? That's the question. the wax did not turn into gas because temperature of boiling water was not high enough. Okay, so temperature was not high enough, and um, for a substance to change from liquid to gas, it must reach its boiling point. Okay, its boiling point. So I'm just writing main points. You have to write: for a substance to change from liquid to gas, it must reach its boiling point. So water boil like at 100 degrees Celsius. So if the boiling point of wax is higher than 100, the heating from water will never provide enough energy to turn wax into gas, right? Okay, let's see next question. So nitrogen react with hydrogen, and what is this forming is ammonia. So two substances which are reacting, they are called reactants, and whatever they are forming, that is called product, final result. So we have to complete this reaction, and it says it is reversible. So reversible is the symbol for reversible is double half-headed arrows like this. Okay, this is the symbol for reversible reaction. It can change from this to this and this to this back again. So this is showing electronic configuration for hydrogen atom. This is one atom of hydrogen. So there is one electron because hydrogen has one electron. This is the molecule, means group of two atom H2. So two hydrogens are there. Okay. So one dot we can write for this hydrogen. Suppose we represent electron as dot, and this we can represent it as a cross. So this and this, and when two electrons are they are combined and they make one single bond. Okay, one electron is from this hydrogen and one is from this, because there are two hydrogen atom which is making hydrogen gas. Okay, next question. So ammonia is reacting with sulfuric acid, and what it is forming is ammonium sulfate. We have to just write it in words. So here we can write ammonia, because this is reactant, we write reactant this side, and then sulfuric acid, this is F, sulfuric acid, and what it is forming is ammonium sulfate. So here we can write ammonium sulfate. So this is product, these two are reactants, we write product after arrow. This is showing that these two are combining, and this is what it is forming. Now we have given ions of ammonia, which is this, these are ions. Ions means charges. So for ammonia it is +1, and for sulfate it is -2. You can see this. We have to write formula. So how do we write? I will write NH4 and SO2. SO4, sorry. What is the charge on NH4? It is plus. Plus means it is just +1. It is 2 here for sulfate, right? I'm not putting charges because in option there is no charge. So I just need these numbers. How do we make formula? Just do cross multiplication. So NH4 and whole, this 2 will go there. SO4, 1. So we don't need to write 1. This is our formula, NH4 to SO4. This is correct, okay? Always just put charges like this underneath them, cross multiply, and you get the formula. Next question, explain why some farmers spread ammonium sulfate in their field. Because it is used as a fertilizer. Ammonium sulfate is used as a fertilizer, and it has two essential nutrients. One is nitrogen, which is important for the growth of plant. Okay, ammonium sulfate contain nitrogen, and it is very important for the growth of plant. This is what you can write: growth of plant. Write one more because it is 2 mark. You can write it is also a source of sulfur. um, this fertilizer ammonium sulfate contains sulfur. Again, sulfate is a form of sulfur that plant can easily absorb, and it is important. It help improve plant resistance. Resistance to what? Resistant to disease. Okay, next. Okay, this is question 3, which says water treatment is needed to make most sources of water suitable for drinking. So there are some processes given like chlorination, filtration, and sedimentation. We have to place them in order. So first, when during water treatment, first is sedimentation. This will go here because large insoluble particles are allowed to settle to bottom, and that is called sedimentation. Okay, if you leave it undisturbed, large particles settle at the bottom. Second is filtration. So this is going to be second one, filtration. Water is passed through layer of sand and gravel to remove small insoluble particles. Third is chlorination. Chlorination is 3. Chlorine is added to kill any remaining bacteria or any microorganism. So these are the steps. So how chlorine atom is converted into chlorine ion? That is the question. So chlorine, any atom convert into ion by losing or gaining electron. So chlorine atom has 7 electrons in outer shell. Okay, so because to um, by gaining one electron which is negatively charged, it can achieve a full outer shell. Okay, because atom need 8 electron to achieve their full outer shell, and that's how they become stable. So it is already having 7. How it will become 8? By gaining one electron, right? So by gaining one electron which is negatively charged, it achieve it achieves a full outer shell and becomes stable. So because it is gaining negative charge, that's why this minus sign come here, and it become negative chlorine ion, chloride ion basically. So if an atom is absorbing or gaining negative charge, it will become negative ion. If an atom is losing negative charge, it will become positive ion because electron is negatively charged particle, so that's why it become negative. So why chlorine is added to water? To kill bacteria from water. So why tap water is not used in chemical reactions and analysis? Because it contain dissolved impurities or ions. Okay, so these dissolved substance could react with chemicals which are being tested, and they can interfere with the result of the analysis. That's why we use distilled and deionized water in chemical or any experiment. Okay, so you have to write because it can contain dissolved substance, impurities, or ions. Okay, next is this question, which is saying a student was asked to distill a sample of tap water, and this is the setup used by student. And the student made an error in setting up apparatus. The error meant this error meant the pure water could not be collected in test tube. Explain what need to student to change so that pure water can be collected in the test tube. Okay. So basically, the main error in the setup is the position of the delivery tube in the receiving test tube. This is the test tube, and this what student need to change is student need to move the end of the delivery tube, this, so that it is not submerged in the water being collected. Okay, it should not be submerged here. If the delivery tube is underwater, suck back can occur, right? When the heat is removed or the temperature drops, the gas inside the apparatus can contract, which can create a vacuum that can pull the cold water from the test tube back to the delivery tube into the hot flask, and this can cause glass to crack or contaminate the pure water. Okay, so this is what you need to change. The student need to change, need to move move the end of delivery tube so that it is not submerged in the water. It is not submerged in water being collected. Okay. State what water should be, what student should use to heat the water. To heat the water, student should use Bunsen burner. Okay. Next we have this one. Question number 4. Let's go here. So question 4 says a student was asked to find volume of lithium hydroxide solution, and that would react exactly with 25 dilute hydrochloric acid, and this is the equipment for carrying out rough titration and then 3 accurate titration. Okay, so what is this equipment called, which is X here, this tube? So this is called burette. So this is correct. Describe how students should measure this of dilute hydrochloric acid accurately into the conical flask. So first, students should use volumetric pipette, specifically 25 centimeter cube, because this much we have to measure. Then we use um, pipette filler to draw liquid up to the mark. Okay, then we ensure the bottom of the curve of the liquid sits exactly on the line at the eye level to avoid any error. Ensure bottom okay, bottom sits exactly on line. Okay, and then fourth is transfer liquid into conical flask and allow it to drain under gravity. Transfer liquid into conical flask and allow it to drain. Okay, next question is this. So this is showing, this table is showing the result of the students titration. Okay, and basically we have to calculate the volume of lithium hydroxide solution added to rough. So this is showing rough titration, right? And how do we calculate volume? By subtracting initial reading from final reading. So initial is this, final is this, so we just subtract them. If we minus this 1.50 from 229.5, let me just, you have to write this, and if you subtract you will get 27.65 centimeter cube, and that's your answer. We have to calculate mean of 3 accurate titration. The formula for mean or average is, first we write sum and then we count them and then we write number of observation in the bottom. So here accurate is these three, right? So, and first we add these three and then we divide it by 3 because they are total 3. Suppose there are 4, so we add 4 and then we divide it by 4. Okay, so by adding these three, if you add them, you'll get 74.10, and we divide it by 3, which will be 24.70 centimeter cube, and that's our answer. The change in color, when methyl orange's indicator was used to dilute it in the conical flask, what change we'll see at the end of the titration? That's the question. So in acid, hydrochloric acid in start is red in color, and at the end it get neutralized and change into orange. So the correct answer is red to orange. Next question is, during the titration, lithium hydroxide react with dilute hydrochloric acid, and it form lithium chloride and water. So we have to write balanced equation. So first, lithium hydroxide, it is reacting with hydrochloric acid, so HCl. What it is forming, what is formed, we write right side, lithium chloride and water, which is H2O. To check if it is balanced, lithium both side is this side. We have one, right? One lithium is there. Let me use, and then the other side we have one. Oxygen is one, one. Hydrogen is one, two. Reactant side, and here we have two, which is balanced. Chlorine is one, one. So it is already balanced. Type of reaction, it is neutralization reaction. Neutralization reaction. Why? Because this is base and this is acid, and they are making, when they are combining, it is forming a salt and water, which is called neutralization reaction. Next question is this, which is there is a chlorine atom given. So this at the bottom we have, this is atomic number. Okay, this is atomic number. Atomic number means number of protons, and this is atomic mass, or we can say mass number. Mass number is number of proton plus neutron, which is inside nucleus. So atomic number is just number of proton, which is 17. So number of proton is 17, and number of proton and electrons are always equal. So if protons are 17, electrons are 17, number of neutron we can find by subtracting atomic number from mass number. So 35 minus 17, which is 18. 18 is number of neutrons. Now we have to calculate, we have given mass for silicon and chlorine atom, and we have to find the empirical formula for silicon chloride. So the first what we do is the mass. First I'm finding for silicon. So okay, first we need to calculate moles of silicon atom. The mass is given for silicon is 1.4, divided by relative mass is given, which is 28. So if we divide, we'll get 0.05 and moles. Similarly, moles of chlorine atom. Chlorine mass is 7.1. We divide it with its mass, which is relative mass 35.5. And mole for chlorine is um, 0.2. And now we divide by the smallest. Out of these two, which one is the smaller? 0.05. So we divide this answer, both of them, with 0.05. So for silicon, the answer is 0.05, and smaller number is 0.05 out of these two. So we get 1. For chlorine, 0.2, and we divide it with a smaller number, which is 0.05, and if we divide this, we'll get 4. So this is what we did it to get the ratio. So the ratio for silicon is 1, and for chlorine is 4. So the ratio of these two are 1 to 4. So using this we can write the formula, because for silicon we got 1 and chlorine 4. So SiCl4, that is the empirical formula. Next is this, in modern periodic table, we know there are rows and columns, which are called groups and periods. We have to tell silicon is found in which group and period. So silicon has atomic number of 14. If we check, the electronic configuration is 2, 8 and 4, right? So because it has electrons in 3 energy shell, it is located in third row. So our period is 3, and it has 4 electrons in its outermost shell, which place it in group 14. So group 14 and period 3. Describe the difference between Mendeleev's periodic table and modern periodic table. So Mendeleev's periodic table, here elements were arranged in increasing order, in according to arranged in order of increasing atomic mass. Mass means proton plus neutron, number of proton plus neutron. Okay, and modern one is here elements are arranged in order of increasing atomic number. Atomic number means just by proton numbers, number of protons. Okay, this is important. Remember this. What is atomic mass and number? And yeah, this is the main difference. Okay. Okay. Next question is this. So question 6 says a 250 centimeter cube solution of copper sulfate contain this much of dissolved solid. Calculate concentration of this copper sulfate solution in gram decimeter cube per decimeter cube. Here mass is given in centimeter cube. We want it in decimeter cube, so we need to convert. So because 1 decimeter cube is equal to 1000 centimeter cube. So if we divide this by 1000, 250 divided by 1000, we'll get 0.25 decimeter cube. Okay, so instead of 250 centimeter cube, we need to use 0.25. And after converting it into decimeter cube, which we got as 0.25, now we will use this formula to find concentration. So mass of solid is given, which is this, right? Here we have to write 6.52 over volume of solution. We just got 0.25 because it says in decimeter cube. That's why we converted it into from centimeter to deci. And if we divide this, we'll get 26.08 gram per decimeter cube, and that's our concentration. Okay, so formula is given. We just need make sure you check the units because they are given in brackets, right? Make sure the values other than this, everything was matching. So you need to convert. Okay, so solid, I mean sodium hydroxide solution and copper, they were reacted together completely, and the result was a mixture of precipitate of copper hydroxide. We have to describe how to obtain pure sample of solid copper hydroxide from mixture and pure sample of sodium sulfate. Okay, so for this, what are the process? First we need to do filtration. First step is filtration. We can pour the mixture through the funnel lined with filter papers. The solid copper hydroxide will be collected on the paper as the residue, right? Then we need to do washing. You have to explain all of this, what I'm saying in here. Washing means we need to wash the residue with a small amount of distilled water to remove any remaining sodium sulfate solution. Third step is drying. Leave the copper hydroxide in a warm place or a drying oven to dry. Then to obtain pure sample, this is for this. Now for solid sodium sulfate, what you need to do is again first step is filtration. Second is evaporation or crystallization. First we evaporate it and then we make crystals, crystallization, okay, and then cool it and or we can say dry it. So we filter the mixture as we did, as I said above here. So the sodium sulfate will be in the liquid that passes through and we call it filtrate. Then filtrate is we put it in evaporating dish until it reaches the point of crystallization, and then we allow remaining solution to cool slowly so that large crystal of sodium sulfate can form, and then we filter these crystal out and pat them dry with filter paper. Okay. Okay, this is our next question. This is C. In this experiment, this is showing equipment used for electrolysis of sodium sulfate solution. Why we use graphite as the electrodes? That's the question. Why we use this material? Because of its excellent conductor, because it is an excellent conductor of electricity. So we can write good or excellent conductor. Good conductor of electricity. Graphite is good conductor of electricity, and it is chemically inert. Okay, chemically inert means it will not react with the electrolyte like with sodium sulfate solution, or it will not react with any other chemical and form other like it will not affect the chemical reaction, and it will not form some new substance. Good conductor, why it is good conductor? Because it has free electrons that move freely and allow current to flow and produce electricity. Next is sodium sulfate solution. It contain ions, right? So which ion will be attracted to positive electrode? So positive electrode, we know that opposite charges attract, like positive and negative, they attract, right? So positive electrode will attract negatively charged ions, right? So positive electrode, it will, if you see here, we have negative charge sulfate and negative OH minus. So positive will attract these two. So this option is correct. Next question is this: draw one straight line from each electrode to predict formed at the electrode at that electrode during the electrolysis of sodium sulfate solution. So basically, here for anode, okay, like at cathode means negative electrode. So positive ions, which is Na plus and H plus, they are attracted to cathode, right? Positive will attract to negative one, and if the metal is more reactive than hydrogen, then hydrogen gas is produced instead of the metal. So here for cathode, hydrogen will be produced. And at the anode means positive electrode, negative ions are attracted to this anode. So if the negative ion is sulfate and nitrate, oxygen gas is produced from the hydroxide ion. So it will form oxygen. So next is this question number 7. So which there are some experiment steps are given, and which is a student is investigating rusting of iron rod, and these are the steps. There are two tube A and B. This is showing the result of investigation and for both tubes. So first, to calculate this, we have to calculate change in mass, which is final mass, initial mass. We subtract them. So this is final mass, this is initial. If you subtract them, you will get 0.56 grams, and this is your change in mass. To find the percentage increase in tube B is this. So change in mass is 0.56 divided by initial mass is 7. This is initial mass, times it with 100. So if you divide it, you will get 0.08, and if you times it with 100, you move this here and you'll get 8%. That's your answer. Okay, so next is this one: um, which gas from the air has reacted with the iron rod in boiling tube B? So rusting is an oxidation reaction. So for iron to rust, it must react with oxygen and water. So basically, the other gases, they are not the option. Oxygen is the correct option. Okay, because rusting of iron is it require oxygen and water for rusting. So why it did not iron did not rust in boiling tube A? Boiling tube A has, you can see, magnesium ribbon, and B does not have magnesium ribbon. So in two cases, it will not rust either, because if the iron did not rust, means boiling. If we remove any oxygen, or if there is no moisture, if oxygen is missing, the iron rod cannot undergo chemical reaction and it will not form rust. So if two things are missing, oxygen and water, it will not rust iron rod. Okay, next is this one. So it is showing some uses of copper metal. In the picture we can see for wires, for cooking, for coins, for pipes. Describe how properties of copper make it suitable for their uses. You, your answer should include use of copper metal and shown in the photographs, and properties should include these. Okay, so first, electrical conductivity. Okay, so electrical conductivity has because copper has a very high electrical conductivity. It is the second highest of all metal after silver. So this make it ideal material for wiring. Okay, it allow current to flow through it with the minimal energy loss through it. And then it malleability and ductility. Copper is highly malleable. That means it can hammered into sheets. And ductile means it can drawn into thin wires. We can make thin wires through it. So again, ductile is for wiring, and that's why we can make pipes and tubes through it, because it is very malleable. Converted, it can convert into sheets. And thermal conductivity, because copper is excellent conductor of heat, which make it perfect for cookwares. Okay, because heat spread quickly and evenly across the base of the pan, and which ensure food cooks efficiently. Then chemical reactivity, copper is its reactivity is very low, its chemical reactivity is low, and that's why it is resistant to corrosion. Okay, corrosion resistant. And it does not react with water. That's why it is used in pipes. Okay, and in fittings. Like unlike iron, it does not rust. So yeah, it can, you know, stay for long period of time without even if it is exposed to water and all. Okay, yeah. Then we have okay. If you want other questions, if you want me to solve other questions, you can join me on Teams, and you can comment for the link. Students who comments only, I will give link to them. Or you can WhatsApp me on this number 919205948909. And I teach math and chemistry, biology, and physics. So we are practicing lots of paper concepts, and I'm giving tricks how to crack your exam, how to even I also if your siblings are preparing for SATs, I take free classes for SATs also, year 6 SATs. Okay, so you can contact me. Thank you. Bye bye.